I'd like to give you an update on the GraphView feature I'm working on for my dialog scripting language. So if you just drop by here accidentally, it's a modeling language for interactive dialogue. So the idea is to define branching interactive dialogue for video games with a very simple yet powerful programming language. So you see an example for the game Mass Effect 2 or dialogue from the game Mass Effect 2 represented in the language. And what I wanted to do is to add a graphical representation of what you actually describe here in order to make the structure of the dialogue more explicit. So let's see how this looks like. And I will just open the graph view, which is a little bit hidden right now, but it's still work in progress. But anyway, let's just create a small example. So I just copied some stuff we need in order to write the dialogue. We need some characters having the conversation, obviously, and some switches and conditions, which I won't elaborate on in this video, just take them as given. And obviously in the graph view nothing happens yet because we don't have written any dialogue. So let's get started with defining a scene, giving it some name, and we want to start our scene with some default dialogue. So dialogue which is played whenever the scene is triggered. I don't know, something like that. And as soon as I save this file, something should appear in the graph view, and it does. So let me just relay out the script to make it more readable. I just use the shortcut Control-Shift-F to do that. And yeah, basically you see a node for the scene, start node, and you see a node representing our defaults construct here, and the dialog which is inside this default construct. So let's add some more dialog, and we want to have some dialog which is only played the very first time the scene is triggered. So maybe something like this, and we want to add some alternative to that. So every other time we want to have skull saying something else, maybe something like this, and I hit Control-Shift-F again to reformat that. And let's just save our changes and see how this reflects in the editor, in the view. So here you see the first time condition, which creates these two branches. So in case of first time we go down this road, and any other time we go down that road. And the default feature of the view is that the text is shortened as soon as it exceeds a specific amount of characters. However, if you want to see the full text in the text nodes and the blue nodes, then you can turn off this feature with this button here, and you get the whole text displayed. But I prefer the shortened version, so I turn it on again. So what else do we have here in the toolbar? We can change the horizontal distance between nodes as well as the vertical distance between nodes. We can turn on and off whether or not we want to see updates. So I just turn it off, which means that when we add something here, so let's add some conditional dialog. So if this condition applies, then you might say hi skull, and alternatively he knows about the actual name, which is Nigel. He might say something like that. Control-Shift-F again, and I save that file now, and nothing should happen here because we just turned off the automatic update. So let's turn it on again and see how this condition is displayed actually. So I just turn it on, and as soon as we change something here and press Control-S, it notices that the model has changed, and it adds this condition. So the conditional node represents the very general condition compared to our first time condition here. So we go down this road in case that has not talked Jake, and in case that nose name is Nigel, we go down that road. Okay, so what else do we have? So the graph is growing here, and one option you have is to change the zoom step. So right now we see it in 100%. We could fit it into our available space, and whenever the graph is smaller than 100%, the fisheye feature of the nodes kicks in. So let's just make it even smaller so you can see it better. You can investigate the nodes by just hovering over and see what's inside with that feature. What you also can do is change the orientation of the graph layout. So if you want to see it from left to right, you just use that toggle button. For example, if you prefer to have the graph view down here, you might want to select this option, while I prefer representation from top to bottom. So let's change it back. So these are the options, and it's pretty interesting for me to work with a graphical representation of a textual model, because it shows how many branches we actually create in this textual model without maybe knowing it. So let's just go back to the bigger example I showed earlier, the Mass Effect example, which again contains these conditions we just saw here already, but it also contains all kinds of hubs, which are basically loops where the player has different choices, and we might exit a hub, so really jumping from that choice to what's next in the script, or explicitly invoking a hub like this, or even invoke another scene. So let me just, where is it? Yeah. So here we have a condition, and we use the enter scene feature in order to invoke the second scene. So we actually have two scenes in this script. So a lot of stuff is going on here, and let's see how the graph looks like. So as you can see, it's getting pretty big, and it's pretty hard for us to see everything. And I mean, okay, the layout might not be perfectly working right now, but it's pretty okay, I think, given the fact that we have cyclic graphs here. So it's not really a tree, it's really a graph. I need to work on the representation, but still we see that the graph is getting pretty big pretty fast, and I'm pretty happy that I don't have to edit this thing, and I only have it as a view. So green nodes indicate hubs. So let's zoom in a little bit and investigate this a little bit in more detail. So why I think that it's pretty valuable to have something like this. Let's look at phase 4 first. Now let's just minimize that a little bit. So where do we have the hub for phase 4? It's represented by this node, and the player has two choices, choice 1 and choice 2, which is called Y grunt, or you want to die. So red connections indicate player choices and path, which are only available after a player choice. So we have this you want to die and Y grunt. And in the end, we have these two dialog lines in every choice. So these two nodes represent, and these two nodes represent the other choice. And in the end, we exit the hub in any case. And this means we end up here. This is why the arrows converge to this dialog line. And that's pretty straightforward. I mean, nothing really surprising here. That's what we expect when we read the textual model, and that's what we actually see when we look at the graph. So let's have a look at phase 2. So this hub contains 3 choices. So we would expect a green node called phase 2, where 3 red connections, outgoing connections exist. So let's have a look. So actually we have 4. So this might be just me making a mistake in the model-to-model transformation, but let me tell you it's not. The reason why we have 4 connections is the following. This choice is empty, so we don't have a dialog line here, but still it's something the player can select and then proceed throughout the script. So when the player selects this choice, it exits the hub, and exiting the hub means we go from here to whatever follows this hub. And in this case, in this specific case, it's a condition. So this is what is represented by this little fellow here. So leave him where he is then, right? This is the choice the player has. Might lead to the dialog within this condition. Very well, Shepherd. This is the node we see here. However, if this condition is not true, we have to, the dialog might as well end up in this parting section. So we have another connection, outgoing connection from phase 2, pointing to the parting section, right? So of course I could use, or I could draw this connection from the conditional to parting as well, but that's just the way I did it so far, and it was pretty surprising to me to see and try to cover all these corner cases, which results in a huge graph, which is, I think, pretty hard to create in the first place, and to not to speak of maintaining it. But that's just my opinion. I'm pretty happy to have this feature in the works, and I'm looking forward to releasing the code on my GitHub repository, as well as a new version of the tool, so you can play around with it and maybe give me some feedback about it. I would be pretty happy to hear what you think about it, having this graphical representation of stuff going on right next to your textual model. So thanks for watching. Have fun.